Hi, everyone. We've set up this Being an Engineer podcast as an industry knowledge repository, if you will. We hope it'll be a tool where engineers can learn about and connect with other companies, technologies, people, resources, and opportunities. So make some connections and enjoy the show.
We're kind of like an extension of your skills or like your hands. I mean, treat us like that we're important, because if we all work together synergistically, we would be so much more efficient and get so much more done.
Hello and welcome to another episode of the Being an Engineer podcast. Today we're speaking with Emma McFadden, who is a senior engineering technician at Philips in their sleep therapy new product development group. Emma holds an associate's degree in electronics engineering technology, a bachelor's degree in technical management, and a master's degree in project management. Emma, thank you so much for joining us today.
Thank you for having me.
All right. Well, what made you decide to go into the engineering and technology space in the first place?
Well, I remember when I was a child watching my dad tear my toys apart to fix them, and I started tearing my toys apart because I was curious what was inside. And I used to watch this show called Mr. Wizard's World, and he was always making things like electromagnets and stuff like that. So I was like 7 when I built my first electromagnet. And then I saw an episode where he built a simple DC motor, so I built one.
Oh, wow. At such a young age. That's awesome.
Yeah. And my dad used to buy me these kits from Radio Shack that you could build different circuits on. So, I mean, I've always been playing around with electronics, and I always loved science. When I was a child, I could probably pick up a rock and tell you if it was igneous, metamorphic, or sedimentary. It was just an urge.
Wow. That's just way over my head already.
Sorry. But
No.
Yeah, I love science and technology.
That's awesome. Very cool. So this was just a passion from a very young age.
Yeah. Yep. As far as I can remember.
Walk us through a day in the life of a technician. I mean, what are some of the common activities that you fill your days with?
So I normally get in early in the morning between 4 and 5 a.m. Where I work, we kind of have flex time. And I work in Pittsburgh and live north of Pittsburgh, so the traffic kind of sucks. So if I get in early, get out early, then I'm good. But I go in, check my emails. If an engineer needs a test set up or something run or something soldered or built or modified, then I try to have it finished before they even get in the office. And through the day, engineers will come down to the lab. Our lab's on the 4th floor, and most of the engineers are on like the 5th, 6th, and 8th floor. And they'll have something that needs modified or build or whatever, and I'll build it for them. Then I'll take it up to them, or they can come get it, and that's pretty much how it goes.
Cool. Okay. I'm curious about the separation of technicians on one floor and engineers on another floor, and is that efficient, or would it be better if you were all on the same floor?
Well, I think it would be better, but they built us this big new building in East Liberty, which is part of Pittsburgh, and it's kind of stacked 9 stories, and it's just logistics. It
is what it is, huh?
Yeah.
Okay. Well, in your experience, what are 1 or 2 ways in which you've seen engineers not working as effectively as possible with technicians?
Well, the biggest thing is, since COVID, we have this working from home thing, and technicians are almost always in the office, and a lot of engineers work from home, and sometimes it's difficult to get the proper communication, or you have engineers that they don't want to have to come in the office, so it kind of makes it hard for us technicians. But that's pretty much the biggest challenge. And well, another challenge is people just don't communicate, don't always share knowledge. And if there was more of that, we would be so much better.
Interesting. So engineers don't want to come into the office, which I mean, I kind of get, right? Like this whole work from home thing, people enjoy that. I have thoughts on that as well. From my perspective, we should always work wherever we're most productive. In fact, core value number 2 here at Pipeline is governed by productivity, not bureaucracy. So work wherever you're most productive. But to your point, it sounds like a lot of the time, or at least sometimes, the most productive place for the engineer to work would be on site. So the two of you can communicate back and forth effectively. But what's the roadblock there? Is it just, I hate to say it this way, but engineers being lazy, or are there other factors that come into play, do you think?
Well, I can't say that they're lazy. I mean, where I work, we're a medical device company, so they get stuck in a lot of meetings and doing a lot of documentation. So I can understand them wanting to work from home. But in my experience, and I've been doing this since 1999, the best things, the best solutions we came up with is when we were working elbow to elbow. Like I got my name on 2 patents with a bunch of engineers, and like we were all working together, really good synergy. It was great. I miss that so much. But but with them working from home, we just don't have that anymore.
And is this a topic of conversation where you work, or I don't know, do people just kind of sweep it under the rug and not talk about it?
I think a little of both happen. Like with technicians, we all know that, and sometimes we feel abused because engineers kind of take advantage of us being in the office and them not. And I think management to some degree recognizes it. However, the world's changed since COVID, and that's kind of the norm now. And I don't know what's going to happen moving forward.
Yeah. Well, that's frustrating, I imagine.
Yeah, a little bit.
Yeah. You also mentioned just general communication. Can you think of ways that engineers and technicians can communicate better? I mean, we talked about being like elbow to elbow, as you put it, right? Which is a really good way to put it. Beyond that, are there other things that technicians and engineers can do to foster better communication?
Well, I think some things have been tried, but it still boils down to we need to be face to face. I mean, that's reality. We need to be working elbow to elbow. I need to be, if they're upstairs in their cube, I need to be able to go up and ask them, not send them an email and wait for a response.
How about web meetings like Teams or Zoom? Can those be effective working between engineers and technicians?
So we use Teams, and sometimes people aren't very good at responding to messages in Teams, and we have a lot of Teams meetings. But once again, you're kind of dependent on the engineer looking for that ping on the Teams.
So if you're pinging an engineer and they don't see it, then the work doesn't get done.
Right. And I mean, they are always in meetings, so I get that. And I hope I don't sound negative toward engineers, because I have a lot of respect. They work very hard, at least where I work. But
yeah,
I would never want to discount that.
Yeah, no, thank you for saying that. I can understand the frustration though. Like you're trying to get something done, and engineers they're in meetings or wherever, not able to respond, and you can't just walk up there and talk to one of them. So I guess you just have to make your best guess or wait, huh? That's what it comes down to.
And a lot of patience.
Yeah. All right. Well, let's see. In addition to your bachelor's degree, you also obtained a master's degree in project management. No small feat. Congratulations on that.
Oh, thanks.
What are a few of the most important skills that you acquired with that degree, and how have you been able to use those at work?
Well, the skills I obtained, the biggest one was emotional intelligence. Are you familiar with that?
I am, yeah. EQ, right? As
Yes.
it's referred to.
Yes. So understanding my emotions, understanding how I react and act affects other people has been super valuable. And it's that in and of itself has made me able to be a better technician. And then the leadership side of it, taking initiative or just being consistent, having integrity. Like, I remember one of my professors saying that people tend to follow somebody's lead who acts and is how they aspire to be. So to be that type of person, then that makes me a better employee all around.
Yeah, for sure. Can you think of, and if you can't, it's fine, I'm kind of putting you on the spot here. Can you think of a particular situation in which this heightened sense of EQ, of emotional intelligence, really helped you solve a problem or resolve some conflict at work?
Well, I work with another technician who's easily excitable, and he's a Marine, or he was a Marine, and it's just his personality, but he's a little rough around the edges. So understanding that helps me to control my emotions and have a much smoother working relationship with him. Does that answer your question?
Yeah. So what's the thought process? Like, something happens and maybe it could be taken, multiple ways. You could just react and be upset or fire back an insult maybe, or something like that. What's the thought process that goes on in your head in those situations?
Well, I have to be mindful of how I feel and think about, how this is impacting me. And then I have to make a choice of how I'm going to react, think about how it's going to affect him, and then react to him or not react or take whatever actions.
Right. Yeah. Let's see. Moving on to kind of another topic here. You have tons of experience soldering PCBs. And for those who have done this occasionally and maybe we want to improve there, are there any, this is probably tough to describe like over a call without being elbow to elbow, right? Actually showing. But are there any pro tips that you can share with those of us who maybe want to get better at this skill?
So if, for example, you're going to solder a processor, it's four-sided, has 128 pins, it's about an inch by inch square. The best trick is to tack one of the pins down and then move to one of the other sides, put a bunch of flux on it, and the flux will help to keep the solder from bridging, but you just get a really fine small bead of solder on the tip of your iron and kind of just make sure you're holding the chip down with your finger or a pair of tweezers or something, and just slide it down. And you might have to do it a couple times, but it'll flow so nicely as long as you have enough flux. And then you just kind of glide the tip down away from the chip. If you do have bridges, and usually the solder, enough of it sticks to the tip that it gets rid of the bridges. Learn that, Sony.
Nice. So this is solder one leg down on one side and then move to the opposite side and start working?
Right, yeah.
Kind of like putting a tire on a car.
Yeah, kind of, yeah.
Cool. Okay. Any other pro tips you can think of?
Well, troubleshooting. That's like finding a short. Is it okay if I kind of move into troubleshooting?
Absolutely. Yeah, please.
So say you have like a 3.3 volt line on, a whole line in the circuit, and it's shorted. So shorts are very difficult to find. So I figured out a trick, and I got laughed at when I told other technicians, so I proved to them that it worked. So if you solder a lead on that line and what it's shorted to, which is usually ground, and you hook a digital multimeter leads to those leads that you soldered on, and you turn it to ohms, and you take the whole board and drench it in isopropyl alcohol, and then you take a heat pencil and you turn the flow way down. And if you move it over the board, when you get to where the short is, it'll change the resistance. Maybe not a lot. Sometimes that doesn't always work. So if you put it to like where it's measuring millivolts, you might get a voltage because of the CPAP effect. Are you familiar with the CPAP effect?
I'm not. No.
You've heard of thermocouples, right?
Yes.
So that's how it works. Don't ask me the physics because I don't know, but when you heat the dissimilar metals, the junction, they create a voltage.
Interesting. Okay. Very cool. Well, I can tell you've done this a lot.
Yeah.
As you work through some of these troubleshooting steps, have you ever identified patterns that patterns of problems, mistakes, design flaws, maybe manufacturing flaws that could have been anticipated during the design phase. And now that you're kind of aware of these patterns, could be communicated to the engineering team so that these don't occur in the future?
Well, I can't say it's necessarily because of the design phase, and stop me if this isn't answering your question properly. But I remember we were developing a product, and the software engineers kept coming back with blown processors, and they were 128-pin processors, and they're kind of a pain in the butt to replace. And it was something simple. They weren't following ESD, and they were frying the chips from simple ESD. So that's like a big thing designing them, that you got to follow ESD.
Yeah. And ESD, electrostatic discharge, what else can you say about that? Like, how do you prevent that from happening in the first place?
Well, ground your wrist with a wrist strap. Use a ESD surface that's dissipative. And if you're moving the board from one area to another, make sure it's in a ESD bag. I mean, it's pretty simple.
Follow some best practices, huh?
Yeah, pretty much.
How would you know if one of these chips had been fried?
Well, a lot of times the board just doesn't work, or beeps, or there's no display, or they just can't talk to it with their, I think they're called emulators or whatever. And yeah, it's pretty easy.
Got it. Okay, so if nothing shows up on the screen, if you don't get communications, one of the things that you could explore right off the bat is whether this chip has been fried.
Right, and sometimes it's as simple as the chip gets really hot.
All right. Well, I'll take a very quick break here and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. And today we're speaking with Emma McFadden. So Emma, one of your responsibilities at work has been to support technologies that are associated with sleep disorders.
Right.
Can you share a little bit about the root cause of these sleep disorders? And then we can talk a little bit about the technology that has been developed to resolve them.
Well, I'm not an expert on the matter of sleep disorders. However, I will share what I do know. So there's obstructive sleep apnea, where when a person sleeps, usually on their back, their muscles relax in their throat, and when that happens, their throat collapses, or at least partially, and that's part of the reason they snore and they have sleep apneas, because their throat's shut. So one of our devices, probably the original CPAP, the idea was if you pressurize the person's airway, it acts almost like an air mattress, and it holds it open so then they can breathe. And our devices can actually, we have different versions of devices, but our more advanced devices can pick up on when the patient snores and change the pressure till they stop snoring. And
interesting. So as you're asleep, is your airway pressurized the entire time?
Yes. Like on our more advanced devices that measure the snores, the respiratory therapist can start it out at like a lower pressure, like maybe 4 centimeters of water, and if they start to snore, it'll gradually raise the pressure until they stop snoring.
Interesting. Okay, so I have not understood how these machines work this whole time. I've never used one, but I assumed that, I don't know, every couple of seconds it would force a breath of air down into your lungs. You know, there would be almost like a puff, but it's actually pressurized the whole time. Yes.
Well, the device I was previously talking about was a CPAP. Now we have bi-level devices, or BiPAP, and you have IPAP and EPAP. IPAP is when the patient's inhaling, EPAP is when they're exhaling. So you have modes that it can sense when you start to inhale, and it'll raise the pressure. And then when you start to exhale, it lowers it back to whatever the EPAP pressure is set at. those are more often than not used to treat patients with central sleep apnea, which is where your brain has trouble regulating your breathing. And those, when they're used for that, they have a spontaneous mode where if it doesn't sense a breath for a certain period of time, it'll do a IPAP to try to get the patient to do an inhale and then an EPAP.
I see.
But
what does PAP stand for?
Positive airway pressure.
What are a few of the biggest technical challenges that your team within the new product development group has had to overcome to bring these devices to market?
That one I'm not sure I have an answer for. Let me think about that. I did look at these questions and think about them. Oh God. Relying on manufacturers that manufacture components, that's a big one. I do a lot of power supply testing, and we'll send the vendor, our test procedures that we do, and they're supposed to run the tests on them, but we get them and they don't pass our tests. And I'll give you an example of one. It's called our back EMF testing. So when the blower speeds up, like if you're inhaling or whatever, and it slows down, well, the software slows it down and it has all that energy, so it dumps it on the V bus, which causes the voltage to spike on V bus. And when you have a switching power supply, you have a circuit inside that's monitoring the output and controlling how the pulse width of the pulse width modulator. And it takes a certain amount of time for it to adjust. So when this blower is slowing down, it dumps all that voltage on the V bus or V bulb, and the power supply circuit sees that. Then the circuit shortens the pulse width, and if it doesn't recover quick enough, the voltage can drop below a certain threshold and cause the device to shut down. So that's one of the tests that I have to do. If I took a CPAP and hooked it to a programmable power supply, it'll probably go into error because of that.
The prototypes that you work with, do they resemble closely the final product, or are these very different, benchtop style R&D prototypes?
So the prototypes, I'm working with the engineers when they're designing the individual circuits at the very beginning, the whole way to the point that we're ready to do engineering builds and pilot builds. The funny thing is they usually know what the device is going to look like before the internals are made. So the poor engineers,
the cosmetic exterior.
Yeah. So the poor engineers have to work around that, which is a challenge.
I bet. Yeah. Let's see. What's a tool that doesn't exist, but if it did, would make your job way easier? Faster, more efficient, higher quality, etc.
Something that makes it easier to find shorts, because if you've ever troubleshot, it's really difficult to find shorts. So
interesting.
That's the big one.
Yeah. Okay. All right, and let's see, just one or two more questions here, and we'll wrap things up. Specifically within the context of your role as an engineering technician, what is one thing that frustrates you, and one thing that brings you joy? So,
a big thing that frustrates me is sometimes engineers and managers don't listen to technicians, and engineers and technicians see the world from different angles. In my opinion, and you can correct me if I'm wrong, but engineers see it more of a theoretical standpoint or a mathematical, where technicians, we see it more as a hands-on, what I can see with my eyes, what I can measure with a meter. And I think if there was a mutual level of respect and listening, we could be so much better of a team. But I've been in situations where I couldn't get engineers to listen to me and managers, and I actually one time had to trick an engineer to get him to listen to me, and my idea ended up working.
That's awesome.
Yeah, which is what I got the 2 patents on.
Oh, wow.
Where I wasn't one of the inventors on the 2 patents.
Which is also really kind of sad, right? I mean, here you are hands-on, like firsthand experience with the technology, right? And an engineer won't listen to you when you say, hey, here's a problem and here are maybe a couple ideas for how to solve it. That's got to be super frustrating and hugely inefficient as far as the work goes.
I agree. There used to be an engineer that worked with us. He went to school to be a physicist, but his title was electrical engineer. And I was the only technician, me and one other when I wasn't available, that he wanted to work with. But I remember being at our RF lab, like him trying to figure out a way to get noise down at a specific frequency. And he would actually listen to my ideas. And some of the times they helped him at least get closer to where he needed to go. And I miss working with him.
Yeah. Wow. Why do you think that discrepancy exists? Like, where does this chasm come from where engineers won't listen to technicians?
Well, to be honest, there were a lot of for-profit schools that put out a lot of bad technicians, and I'm pretty sure that's why it's like that.
Interesting. Huh. So at some point, there was maybe this legitimate reason to not trust what your technician was saying in some areas, maybe.
Right.
Do you think that has largely changed?
Not really. No.
And conversely, there's certainly engineers out there that aren't the greatest either. Like, they have their degree, their piece of paper, but they don't really know what they're doing.
Right. That's true.
So it works on both sides, I think.
I agree.
All right. Well, Emma, thank you so much for spending some time with me today. Is there anything else that we haven't talked about that you think would be interesting or useful, especially for engineers to hear about, like how to work really well with technicians?
Well, we're kind of like an extension of your skills, or like your hands, I guess you could say, in a way. So, I mean, treat us like that we're important, because if we all work together synergistically, we would be so much more efficient and get so much more done, and probably be happier too.
Man, I hear you. I hear you, and I wish there was something more that I could do. I'm 100% in your camp, Emma. I think that technicians and engineers should be working very closely. We have a couple of technicians here at Pipeline, and they're constantly back and forth. The technician will come and pull the engineer out of his seat and, hey, come back and take a look at this with me, and they'll go look at it together and they'll brainstorm and figure something out. And I can't even imagine not having a strong relationship between your technicians and your engineers. It just seems wildly inefficient. And to your point, not a very joyful environment in which to work.
For the most part, there are some engineers that I work with that actually started out as technicians and then went back to school. And they're some of the best engineers I've ever worked with.
I have no doubt. Yeah. They have the hands-on experience, right? And the engineering know-how. That's a potent combination for sure.
Very, very much so.
Yeah. Well, Emma, thank you again so much for spending some time with me today. How can people get a hold of you?
I'm on LinkedIn, so you could look me up on there. That's probably the best way. I always check it regularly.
Okay, excellent. Well, thank you so much again, Emma, for being on the show with me today.
No problem. Glad to be here.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.